Hello to everyone. I'm Hossein Zare from Sharif University of Technology. I'm going to present our paper on water resource dynamics Chabahar free zone case study. As you may know, Chabahar is one of the free zones in Iran, and its improvement and its development is very important because it has a great a strategic location, and because it is located in southern part of Iran, so its development depends on water supply and water resources significantly. Here you can see some of previous researches on water resource management, but we are going to present a novel hierarchical system dynamics simulation in order to uh, simulate the water resource dynamics. Here you can see our hierarchy. At the first level, we just consider the primary subsystems of the system and interrelation between them in order to have a general view of the system. At the second level, we are going to be more detailed, and we will break down the primary subsystems which we determined in previous level. And at the end, we are going to formalize the causal loop of the level 2, and we are going to have our stack and flow diagram. Uh, Here we are going to review our general view of the system. The first level, you can see here we have two sides. One side for water supply and water infrastructures, and another side is for consumption and the demand side. You can see that the interrelation and the link between two sides is investment. So it's our general view of the model. At the second level, we are going to break down each part. In this level, we have three major loops and three minor loops. The major loops are the dominant loops of our model, and the minor loops are the loops which is going to maintain the relation between the major loops. We have budget, agriculture, and urban consumption as our major loops, and population, desalination facilities, volume of water in sewage for our minor loops. The first one is budget. In this loop, you can see that how the budget is provided for the project by the development in industry. Uh, it is going to be more investment in the area, and part of this investment will go for water infrastructure and related projects. So as a result, industry will develop, and this investment will be more, and the loops go on. At the second major loop, we have agriculture. Uh, for agriculture in an arid area such like Chabahar, uh, the most important factor is having enough water. And when you have enough water, by increasing in the amount of water, you can develop agriculture, and by the development of agriculture, uh, a potential need for machinery, agriculture, agricultural machinery is will be appear here. Uh, so the industry part will be activated, and these bring investment on Chabahar, and you can see the rest of the loop. As the last major loop, we have urban consumption. The more fresh water will bring more attraction for the region. And when the region is more attracted, it can absorb the people from other cities, and the migration will be higher in the area, and population will increase, so urban consumption will increase too. The minor loops, as I said, uh, are the loops which is going to relate the major loops together. So we have population loops. In this loop, mm, by means of job opportunity, we link budget loop and urban consumption loop. You can see that by development in industry, job opportunity will increase, and it will affect region attractiveness, because uh, it is going to be a great opportunity for other unemployed people in other cities. Uh, as the second minor loops, we have desalination facilities. It explains that how the source of providing water and supplying water for the region uh, is going to affect freshwater volume. You can see that by increasing in water supply productions, such as desalination facilities, water purification, we will have more fresh water. As the second minor loops, we have the volume of water in sewage. Uh, when urban consumption increases, the volume of water in sewage will increase, because and it will bring us a potential, a more potential to purify this polluted water, and use them in different parts of our industry and agriculture, or for urban consumption. So we have here the detailed view of our model. We are going to formalize our model and construct a stock and flow diagram. Here we have six stock variable, which is going to uh, mm, explain the behavior of our model: population, volume of water in sewage, volume of water in desalination, freshwater volume, area under cultivation, which measure the areas that we are going to uh, have agriculture on that. And here, and the last one is industrial companies. So you can see here, we have one stock for population. It has one rate variable, which determine which is determined by net increase in population coefficient and migration. Two effect will uh, determine our migration here: effect of water on migration and effect of employment on migration. In order to quantify these qualitative variables, uh, we used lookup functions. So you can see here's a nonlinear pattern that explains the behavior of attractiveness from water and employment. Here we have volume of water in sewage. You can see by the urban water consumption, volume of water in the sewage will increase, and after purifying this water, uh, we will use this purified water in three different fields. The first one will be urban consumption, the most purified water. Some of them are going to be used in industrial companies, and some of them in agricultural stuff. You can here we have volume water in desalination. The This stock measures the amount of water that are being processed to be desalinated, and the input rate of it depends on our capacity, because Chabahar is located near the Persian Gulf. We have no limit on water, and the desalination rate, a delay for desalinating will determine our output rate. Uh, for freshwater volume, we have different source of supply. Uh, Here is rainfall and ground water level, and another one is purified water, which is from volume of water in sewage, and urban consumption will decrease the freshwater volume. In order to involve agriculture in our model, we consider a stock named area under cultivation. This measures the area that is being cultivated, and it is being used for agriculture now in every period. So we have considered three important factors as uh, the requirement for developing area under cultivation, and these are workers that needed, water needed, and fertilizer. We involved fertilizer here because we wanted to um, mm, uh, involve industry in our model, and uh, according to our researchers, one of the most dominant mm, industries in Chabahar is going to be fertilizer industry, because some companies are uh, planning to be established, and an erosion rate is considered too. Here we have industrial companies. For development of industrial companies, we have considered three important factors. The budget we need for development, and the workers, and water, as well as area under cultivation. And we have a bankruptcy rate for the output rate of the stock. Here is our resultant validation. You can see here the behavior of industrial companies. Uh, we consider the companies which produce fertilizer in industrial companies as industrial companies. The beginning year is 2006. As you see in the graph, around the 20th period, the industrial companies will grow from zero, and after 80 or 70 period, it is going to be a steady, which is true according our news about Chabahar, because there's a plan for establishing the fertilizer producer companies in Chabahar. During future years, we predict that some of them are going to be established around 2025. So we have the behavior of freshwater volume here. The bar chart is from the real data, and the curve is the result of our model. You can see that both of them have a similar behavior. They will grow until 50 period, and after that will decrease. We have the trend of population. The right picture will show the difference between our model prediction and the real data, but the trend is the same, and it's the result for our population. So after the validating the model, we adopted some policies and try some scenarios on scenarios on the model, and the most important and the most useful scenario was a variable budget coefficient. In the original model, we used a constant coefficient to distribute the budget among agriculture, industry, and uh, desalination facilities. But as a policy, we decided to um, let this coefficient be variable, and they will and the model will determine them according to uh, uh, the importance of each part. We consider the metric for the importance of each part, and it will determine the coefficient. You can see the difference between the behavior after and before adopting the policy. uh, the freshwater volume will be steady after adopting the policy, and the rate of population growth will be much lower um, in adopting this policy, and you can see the benefits of adopting this policy. Here are our references, and thank you for your attention. The end.